Okay, now the decreasing time priority list. Here we go. Same old, same old. Remember, the people that don't do, they just start grabbing at tasks. Decreasing is you pick the highest one first of the available open tasks, and then you go from there. I'm going to have some goofball pick that one, right? And if you look up at the thing, T5, I believe, is baking the chicken. You didn't even defrost it, remove the skin. Come on, what are you doing? All right, so you're doing nothing. You're not doing what the whole idea of this situation is, which is optimizing, getting a whole job done using tasks that are open to start off with. So decrease, and we pick highest to lowest that are available. So we have three that are open, or four, I'm sorry, that are open. Here we go again about possibly, having some possibilities here for the second person. But the first one, no. The biggest one is the 15-minute task one, which I believe was one of the chicken things. I think I did do that. I think this was chicken, potatoes, corn, table, setting the table, just so we know what we're starting, just for fun. All right, so I'll start by peeling the chicken. Who cares? All right, now person two. You know what? I'm just gonna pick T6 this time. We do have options on this. If you didn't pick T6 first, um, I'm actually not sure what will happen. So this will not happen on the test. I will not have. I'll have the numbers a little mixed up a little bit differently. That you will have only one specific thing, no possible different answers. Okay, here's the situation. What I tell you to do. These get going. These get going. They're not finished yet. Okay, who gets done first? Well, you can look at this. Oh, and I didn't put T6 below that there. You want to mark which tasks you started here. Well, this one gets done before this task 1 by processor 1 is done. So now processor 2 is open, and they have two tasks that they can do. And I'm just going to go right on down the line this time, going in order of the numbers. I don't know why I looked at that. I don't think it ended up being a difference. But like I said, don't worry about this too much. I'll make it more unique when it comes to your time to actually get right answers. So now this is going, but as this is going, this person gets finished, and that's how you want to do this. And then circle up the new open tasks. Okay? Um, so this is still going while this person gets opened up. This is why you want to do the graph as it is. Okay, so now that just leaves two circles that are open. Wait, did I make a mistake? Oh boy, I did. That was open when T6 finished. Not bad, dogs. Roof. Okay, so did he do, let me pause for a second to make sure I didn't make a mistake there. No, I didn't. When that was finished, T5 was open, but still 10 minutes is longer than 5, and this is a decreasing time priority list, so you want to pick the highest numbers that are open first, which means T14 is now open for processor 1. 10 minutes, and at some point, or it could be at all points, you just don't want to get lost in this. Just know that this is 25 minutes in. You could simply count 15 plus 10 to get that done, but just to compare them, that little dotted line is helpful. So you started T14, and obviously, this one's, we'll cross it off when it's done, but it doesn't ever open up T15. T15 served a dinner where everything else needs to be done. Keep reiterating that. For those that pay attention and focus, it's pretty simple. All right, but that means this is going, so this is out of action. And as this person starts T14, processor 2 is open, and then T9 is finished, so I didn't forget that. Now that T9 is done, this one has been open. This one's being worked on. That's what this means signal-wise. And then you have these three that you can do. In the decreasing time priority list, you want to select the one that is the highest. Go from highest to lowest. That's what decreasing means. And that's 10 minutes. And my dotted line is now in the way. It's okay. And then that's T10. All right. So now you open up that task. You start doing it. And during the time that this T10 is open, T14 is done. So this is done, and that's when you cross it off, okay? Does not open this up. Said this before, wasting time. So T10 is being done. Now it's one or the other. All right, this is at 25. This is at 30. So this is good. This ends up being, well, this is working out real nicely. This is 5 minutes. I'm just going to pick T2. It could have been T7. Doesn't matter which one it is. Now what happens is something glorious. Right when they finish T2, T10 is finished. So both processors open up at the same time. So we can close these tasks off. This one is actually opened. This one is not because it has 3 other precedence relations. And that's the idea that you want to get here. So now we have T3 and T7. Well, it doesn't really matter. I'm probably just going to go in order. This is 5, and they're smack dab 10, 20, 30, 15, 25, 30. They're smack dab of being open at the same time. And it's so weird that you have 2 5-minute tasks that are open as well. T3 and T7. I'm just going to give T3 here and T7 there. Then they do these tasks. This opens because this finishes at the same time from your look down there as this one. Well, all that does is open up both of these, and I'm probably just going to, all right, so I'm going to assign processor 1 first. It's the decreasing, so I'm going to give processor 1 the 30-minute task. Right now we're at 35 minutes. Might want to note that or just be aware of it, because then that makes us up to 65. Yeah, I just want to make sure I looked at that 30 correct. So that's 30. This is at 65. All right, and that is T8. Now, I wouldn't be mad at you if you put 30 down here and 15 up there, only because they are right open at the same time. But in the theory, we're probably giving the first task to processor 1 and then go to processor 2. But anyway, and that was 15 minutes. I just want to make sure we're at 35 plus 15 is 50. Really want to make sure you're careful on that. And that is T4. Now look at the graph here and understand that I've started this task, but then I did this task and it finishes. So that's done. Okay. So T4 is done. Processor 2 is open as T8 is being worked on by processor 1. So processor 2 is open. I don't know if I said that right. And it's the decreasing priority list. These are both open, by the way. Nothing else is open because this is in action. This is not finished yet. So I'm going to assign the 45-minute thing. Okay, so 45 minutes. 50, that goes to 95. Yeah, don't ever look back up at the thing if this makes sense. I think this is bake it or something like that. You could do some other tasks during the baking. We're doing these silly little examples. In the real world, this task had to be worked on by one person for 45 minutes. You know, that's the idea. So this one is open. That's what that means, so you know not to look at it anymore. During this time that this is on, this gets finished. So therefore, T11 is now open. I could do that for 2 minutes. I'll add this up after. Wrong. Sorry, I gotta go back. I did that wrong. Bad, Mr. Samuels, bad. Okay. 2 tasks are open. The T13 or T11 in the decreasing priority list. 75 minutes. You want to do the 10-minute task, which is T13. Then you finish this. Okay, it doesn't open this up yet because 45-minute task isn't done. That's not finished there. So then I'll go to the 2-minute task. Where did we end up there? I think I did that way too big. So I got off a scale here. We were at 75. That should be at 77. Gonna cheat. 77. Right? Nice little 77 there. It's scary. 2 minutes. And that's T11. And then that gets finished because this is still being worked on. So then processor 1 could do T12, which is 5 minutes. Let's cheat now and make that look like it's 85. Nah, that's not. 5, these bars should be adjusted. T12. Then this gets done while this is still being worked on. And then finally, the 45-minute task is finished. Then we're allowed to serve the dinner. I couldn't care less who you assign this to, but what you do have to make note of is this. That was 85. If you add this up again, 15. Oh, I hope I didn't. No, I think that's going to be 87. What am I doing? I think that's 82. Boy, I never was good at math. 25, 30, 35, 65, 75, 77, 82. That's 82-minute mark that this person worked up to. This is the 95-minute mark. Okay, what I'm marking is and trying to show you that idle time is coming up. Then we could do the T15. I couldn't care less who you give this to. What we want to understand though is this got finished in 100 minutes, right? Which was better than our last one. So in this case, this particular algorithm worked better and actually got our job done quicker by 12 minutes. Still not optimal because 90 minutes was the critical time. So job done in 100 minutes. And then idle time, that's what I was trying to note there by being careful on my number line, which I wasn't very. This is idle time for, we'll call it processor 1. Doesn't matter who you assign it to. It's either processor 1 or processor 2 that is sitting around doing nothing. So that's from 82 to 100. That's 18 minutes of downtime by one of the workers. Okay? So a little better situation doing the decrease. Doesn't mean that always happens. That's why you have these algorithms. One may end up equaling or being better than the other one. All right. This is more for, we'll have questions along this lines in some way, shape, or form on Thursday with these. Tuesdays and Wednesdays quiz probably more on the general side of the questions. Okay? All right. Good luck.